Hello everyone, so I think we can get started. So first of all, let me introduce myself. So my name is Sergey. I'm from Lviv, Ukraine. I work at the company Logica, and also I'm a part of program committee of Morning at Logica meetup. So if you did not plan to visit Lviv, here's a valid reason for you to visit Lviv. And if you already have plans, then here's an attraction for you in Lviv. Okay, so before we will get started, I want to tell you a story that you may probably heard today. It's a story about Mars Climate Orbiter. So maybe you already noticed that I'm a big fan of space exploration and Mars exploration in particularly. So Mars Climate Orbiter was a space program that was sent to Mars to explore the climate of Mars. It was sent in 1998, and everything was working fine until 33 of September 1999, when it arrived to the Mars. It's supposed to make a maneuver and enter the orbit of Mars at the distance of 226 kilometers from the surface. Instead, it entered the atmosphere of Mars at the distance of 57 kilometers. And get destroyed. It burned out in the atmosphere of Mars. The problem was that two different teams that was involved in developing this orbiter was using a different measurement units. One team was using English measurement units and another was using metric units, and they did not convert it correctly. So this is like a simple problem that could be avoided. But let's see what actually causes the failure. So when we are talking about fault tolerance, we should talk about three things, three terms. It's a fault, error, and failure. First is a fault. Fault is a bug in your system, some incorrect defect in the system, incorrect state of the system. So in case of Mars Climate Orbiter, mixing up different measurement units, it's a fault. Fault causes an error. Error is something that user could observe. It's incorrect system behavior. So in case of Mars Climate Orbiter, entering the atmosphere of Mars, it's an error. It's something that the operators could notice. And error can lead to a failure. A failure is a broken system when the main functionality of your application does not work. In case of Mars Climate Orbiter, a broken orbiter is a failure. So what does it mean to be fault tolerant? Does it mean that the system should not have any faults, any errors? Before answering that question, I want to tell you another story about another Mars exploration program, which is called Mars Exploration Rover. Maybe all of you already heard about this exploration program. It consists of two twin rovers, Spirit and Opportunity. Each of these rovers was supposed to serve on the planet Mars for 90 sols. Sol, it's a day on Mars. Instead, Spirit lasted for 2,210 sols, which is about 5.5 years. And Opportunity lasted for 5,352 sols, which is 15 years. Actually, officially, program was terminated this year, at the beginning of this year. Does it mean that during this period of time, these rovers did not have any faults? Of course not. For example, Spirit got a broken wheel, which make the operators of the rover move it backward, because it was not possible to move this rover forward. So in the same way as this rover experienced a lot of failures, a lot of errors, but it continued to serve on Mars and actually served much longer than it was supposed to. In the same way, the applications that we as engineers are building will have these failures and will have the errors. But still, it's supposed to last. It's supposed to sustain these errors. And today we are going to look at two tools that can help us in achieving this goal. This is Kubernetes and Istio. For those of you who is not familiar with Kubernetes and Istio, I will just say a few words. So Kubernetes, it's an orchestration tool that using the control plane will make sure that your application is running across your cluster. So you have a Kubernetes cluster and control plane will do all the work for you. And Istio adds another level of abstraction by adding a so-called sidecar proxy. It's just a simple reverse proxy. In case of Istio, it's an envoy proxy. And this actually allows you to manage the network and to have a lot of features. I'm not going to go deep into explanation of Kubernetes and Istio. This talk is a little bit about other thing. If you're interested in that, you could find a lot of great talks about it, including my talk about Istio. You can find it on YouTube, it's available. So let's go to explore Mars. First of all, what do we need to explore Mars? We will need a rover that will cross across the Mars and make some exploration, will scan for different stuff. But the rover cannot work by itself, so that's why we need a ground control. Ground control will send the name to our rover and the coordinates of other rovers, so actually our rover that will do exploration. And the rover will send his coordinates to ground control. But as you maybe know, the Mars is not really friendly environment, and that's why we need to have an orbiter that will scan for different events on Mars. And it will send the coordinates of these events. This could be some meteors just falling on the surface of Mars, or this could be underground water. This is actually water, if you're thinking what this thing is. So the rover can scan for underground water. And we also have a lander that, using the coordinates from event rover and the coordinates of our rover, will send some ground events to our rover. It could be a dust storm, or it could be some alien form of life. So all of this stuff that I'm just explaining, you may wonder what I'm talking about. This is actually a game that I have built. It's running in the Kubernetes cluster right now. And I have to confess, because I did a terrible thing to run this game, I wrote some JavaScript code for UI. So sorry for that. But let's take a look how our game looks like. Okay, let me switch to browser. So first of all, this is how the topology of my services looks like. The quality is not very good, so let's not take a look to this too much. Okay, so this is the game. As you can see, I have a rover. It can move forward and backward. And it can jump. So you can see that we have some meteors falling from the sky. If I hit the meteor, the live, I have here on the left top corner, I have lives, will go down. And I can scan for the water. Water gives me 20 points. And this is an alien. He's a friendly one. We can collect them. It will give me 5 points. And here on the top, you can see my name. I'm Zeus from Orbital Science. And the leaderboard, so you can see the top players right now in this game. Okay, so let me deploy a new version of the service and see what could go wrong. Okay. So I'm deploying the new version. Okay, let's see that it actually gets deployed. So you can see that we have a new version of the service. It's initializing. Let me refresh the game. I can close it for now. So let's see what could go wrong. For now, everything looks okay. So we have meteors falling from the sky. I can hit them. I can collect aliens. So everything seems fine. Okay, let's wait a bit. Let me refresh the game so I'm not getting the high score. So after a while, we can see that we don't get the meteors anymore. So obviously, something goes wrong. And even more, we don't have any events. We are just driving on the surface of Mars. Nothing goes wrong. And suddenly, there's a meteor. So what actually goes wrong? Let's see how our services feels. If we will take a look at the event service here, we can see that we have one restart. So this is one thing that you will get for free from Kubernetes. When your service, your service running in container will crash, Kubernetes automatically will restart your service. However, you can see that for now, when our service crashes, there is no other service that can handle our events. So we need some redundancy for this. What we can do, we can manually scale our services. Let me do that. Because deployment. Okay, so oops. I can set up the number of instances of the service that I need. Maybe 2, but I think that 2 is not enough. We can set 3, or even, I think 4. 4 will be good for us. So if we are getting to take a look at our services, we can see that for now we have 4 instances. One of it is crashing, another is initializing. And now, if I will refresh the game, you can see that I'm moving forward. Everything works fine. I'm constantly getting the events. I can touch the dust storm, which will take 1 life from me. So everything works fine. However, if we will take a look at our services, we will see that we still get restarts because our services is constantly crashing. And even though it's crashing, we have another service that can handle the events for us. Okay, so let me clean up. But this is not always the case because sometimes your service could still not be available, however, it will not crash. So let me refresh it. And you can see that there are no events again, so obviously something goes wrong again. However, our services should be fine for now. Okay, so this one will be terminated in a while. Let me refresh the game so we are making sure. So again, we are not receiving any events, but our services, there is no restarts. Only this one, it's the previous version of it. So we can see that services are running fine. What actually goes wrong is that services cannot handle the requests, but it did not crash. So for that, we have to set up some health check. And Kubernetes allows you to set up this health check. Let me deploy this. Service. And this is called probes in Kubernetes. You can set up the probes, and whenever this health check fails, Kubernetes will know that service is unhealthy. So it will restart your service automatically. Let us take a look at it. So, okay, we should wait for a while, so it will get deployed. And we can see that for now we have this pods terminating because obviously something goes wrong, the health check failed, and Kubernetes knows that it should restart the service. So we can see that here we have one service that is restarting. Okay, let me take a look. Okay, something goes wrong with our events. Okay, so we are getting the errors, but the Kubernetes will restart the services for us. We can see that we have here 2 restarts, here 1 restart. We are not getting the events somehow. Which is kind of weird. It shouldn't supposed to be like that. Okay, let me apply the cleanup. Okay, so let's return to presentation and recap the features that we just saw. So first of all, we saw the self-healing mechanism of Kubernetes. So it means that when our services fail, the Kubernetes will automatically make sure that it is restarted. And also we saw the mechanism of manual scaling. So we can set up the number of replicas that we want from our service. And Kubernetes will make sure that the number of replicas that we wanted is always up and running. This is just a manual scaling, but also Kubernetes allow you to do auto-scaling mechanism. So you have actually a few type of auto-scaling. It's a horizontal auto-scaling, which will increase the number of instances based off the CPU metrics or any custom metric that you want. This is a vertical scaling, which will increase the amount of resource that is needed for our service. And there is cluster autoscaler, which can increase the number of nodes inside of your Kubernetes cluster. And also we have seen the mechanism of health check. We have seen the liveness probe, which will make Kubernetes restart the service that is not available, even if it's not crashed. Also we have a readiness probe that can just eliminate the service from the pool if it's not healthy, but we know that it could get healthy in some time. And there's a startup probe for the services that take a while to start. This is how it looks like. I hope you can see it well. So this is a Kubernetes configuration for readiness probe. And in the same way, you can actually set up the startup probe and the liveness probe for it. So we have seen some issues, but in this case that we have seen, we know where the problem is. But when we are talking about microservice architecture, it's a complex architecture. And we do not know all the time where the problem is. For this, we have to set up the monitoring tools. For now, there's a lot of tools available for the cloud applications. You can choose whatever fits you better. And whichever tool will you choose, Istio can help you with sending the telemetry to these tools by using the component called Istio Mixer. All of the sidecar proxies will send a lot of data to the mixer. And by using the adapter mechanism, you can send whatever it's tracing, metrics, logging, whatever data you need. It will send to the needed adapter. So it could be Grafana, it could be Prometheus, whatever. OK, so let's see once again what can go wrong. OK, so let me refresh. So we can see that now everything works fine. And let me apply some, just a minute. Let me apply some errors. So I will break our player service and the event service. OK, so let's see that it's deploying. OK, so it deploys a new broken version of our service. For now, it's not available because it's starting up still. Let's wait for some time. Now, it should be fine. OK, so first problem that we can see that there is no leaderboard, obviously. So something goes wrong. The second problem, we can see that there is no ground events. So we are receiving it, but with some huge delay. So you can see we are collecting the alien. Okay, let me restart. So we are seeing that in some time, we should see that it's blinking. Okay, so we can see, again, there is no leaderboard and there is no ground events. Obviously, it's not how we expect the things to go. Let's see at some monitoring tools that are available with Istio. And first of all, let's see at Grafana. Let's fix the problem with the player service. Let's go to the dashboard, select player service. And if we will take a look at the number of, at the success rate here, so I will try to zoom it in, we can see that it's not 100%. So we are getting some errors sometime. The simplest thing that you could do is set up some retries. Istio allows you to do that without changing your code. So let me apply the configuration for the retries. OK, so retries player service. OK, let's go back to our game. OK, so it's not applied yet. OK, so now we should see that it's not blinking anymore. So we can move forward. And everything works fine. Even though our successful rate is not 100%, we are doing retries and making sure that the requests will pass. The second thing, let's take a look at the ground event service, because as we can see, we are not receiving the ground events as often as we want to. So, OK, ground event service, let me refresh it. OK, something. Let me see if this service is alive. Yes. OK. Still, dashboard, so ground event service. There is no metrics here somehow. Let's take a look at other metric mechanism that we have, which is distributed tracing. So, here, you mean, yeah? Okay, yeah, so there's not what I'm expecting. Let's put it like that. So, yeah, here are some metrics. However, let's take a look at the Jaeger, which is distributed tracing mechanism. Maybe some of you was using Zipkin from Spring Cloud. Jaeger is the same distributed tracing mechanism. Let's find the traces for here, and let me put actually the custom time range because I don't want to see everything. So it's 1755. Let's make it like this and 03. Okay, so here we can see that we have the traces. Everything works fine, but if we take a look at the duration of this requests, we can see that some of them takes 10 seconds, some of them even 20 seconds. Let's take a look at one of these requests. For example, this one. Here we can see that the problem actually is not in the ground event service, but in the event service. So if we take a look at all of these requests, we can see that only some of them takes up to 10 seconds. So what we can do, we can actually set the timeout for the event service. So instead of waiting 10 seconds, we will just fail with an error and return an empty list, an empty events instead of this, and will allow the game to make one more request. Okay, so let me apply this configuration. Okay, let me refresh it. We can see that now we have ground events. Now we have the leaderboard, which is not blinking anymore. I can still hit the meteors, so let me restart the game. So for now, everything works fine. Even though there are errors, there are some delays, we first of all make some retries in case of player service failing, and in case of event service taking too long, we just fail with an error, with a timeout, and allow the game to make one more request. So let me apply the cleanup and go back to the presentation. So we have seen already the resiliency feature of Istio, which will allow you to make a retry in case of a failing error, and will allow you to set some timeout in case in case the request takes too long. One better solution maybe for handling this type of errors could be caching. So for now we are just failing silently. We could choose to return some cached result in case of if something fails. Unfortunately, Istio for now does not support any caching mechanism, any fallback options with caching, but I'm sure that most of us is using one thing that already has built-in caching mechanism, a powerful built-in caching mechanism, and this thing is called HTTP. And I want to talk about cache control header, which obviously controls caching mechanism. And I want to talk about two specific options. First option is stale while revalidate, that you could set for the cache control mechanism. What does it mean? It means that in case if you have some cached result, and you know that this request could take a while, you can get the stale cached result and send another asynchronous request to update the value in the cache. This could work fine for our case with the event service, because the request to event service take too long, and we could choose to get the cached result and make a synchronous call to update the cache. The second one is stale if error. So in case if we know that our service could return an error, instead of getting the error, we can choose to return the cached result. So it's better to get sometimes the cached result instead of getting the error to the user. This is, I hope you can see it, but I'm not really sure. This is the configuration that you can set up for this. But with this mechanism, not everything is so fine. And this thing is called browser support. As you can see, for the stale while revalidate, only a few browsers support this option. And for stale if error, none of the browsers support this option, because it's experimental feature and it's not the standard yet. But when it will become a standard, you can use it right away, and it will help you to make more resilient application. One more thing that can go wrong, it's when your service receives more requests than it could handle. And in this case, it will fail. So for example, if your service can handle 1,000 requests per second, and you will receive 2,000 events per second, it will just fail, and all 2,000 users that is using your service for now will be affected. And this is what usually in Ukraine happens when you want to buy some online railway tickets, for example, before New Year. I experience this every year, and I'm sure that I will be experiencing this in this year. So instead of that, you could use a circuit breaker mechanism of Istio, which will allow you to set the number of requests that your service can handle, and also the number of requests that can be in the pending state and wait for free slots to be handled. All the other requests will fail before getting to your service. And in this case, not all the users will receive the desired behavior, but at least some part of the users can use your service. This is some global configuration that you can set up on your cluster. There is one more option, which is rate limiting, where you can set up this for particular client. This is very useful if you are providing some public API. So you can set up the number of requests that is allowed per client. All other requests will fail. And even more, you can set up for a type of client. So for example, if you have a premium client, you can set up the rate limit higher, and for freemium client, lower. One more important thing when building fault-tolerant application is to build inside of your organization a fault-tolerant mindset. One and very good example of building this fault-tolerant mindset is at a company called Netflix with a tool called Chaos Monkey, which just starts the chaos engineering practice. So it's just a tool that goes to production and kills some service in production. Now they have the whole army of different monkeys that is trying to kill their application. If you're doing chaos engineering already, it's good for you. But if not, I would not suggest you to go to production and just set up the whole army to your application, because definitely it won't sustain. And it's good to start small. By starting small, you can use Istio with the fault injection mechanism. So we can set up some errors for your service or some delays to emulate some slow network or to emulate some high latency. Okay, so let's go back to our application and see the thing that we just discussed. So first of all, let me set up the rate limits. So for now, I have the Rover heads from Rocket Lab. So, oops, I didn't run the cleanup. Okay, let us wait for the services to be deployed. Okay, so first of all, let's set up the rate limits. In this configuration, which you probably won't be able to see because of the resolution of the screen, I have a rate limits that will give the possibility for all the user to have one request to event service per 5 seconds. And for the users from Rocket Lab, yeah, it's good, I will give the possibility to have 500 requests per second. So let me apply this configuration. Apply rate limit. So as I'm a Rover from Rocket Lab, I should not experience any errors for now. So everything works fine. We are getting the requests as we are expecting. But if I refresh the game, now I'm a Rover called Cassandra from Virgin Galactic. If I move forward, I should see that sometimes I'm getting the requests with status code 429, which is too many requests. So this is because of rate limiting. Instead of allowing the user to make a lot of requests, we are just giving sorry, but you are allowed only to do one request per 5 seconds. Okay, so now the most interesting part, it's time for you to play the game. So first of all, let me, just a minute, I will do the cleanup. Okay, so you can scan this QR code and try to play the game. And for the best player, I actually have a present. So try to do your best. So if you didn't scan the QR code, it's explorer.istiodemo.xyz. So let me refresh the game. As you know, the best chaos engineering is the chaos engineering that you are doing in production. So let me try to apply some errors while you're playing the game. First of all, let me apply which one? Fault injection to player service. So now if you were playing the game without deploying the new version, you should be affected by this, and the leaderboard should be blinking from time to time. So I will show this. You can see that it's blinking. Even though the player service is healthy, because it's not the version that I have deployed before, you can see that it's blinking from time to time. Let me try to inject some more errors. I will inject the delay to event service for the Meteor endpoint. So for now, you can see that I'm moving forward, and there is no meteors because there is a pending request that can take up to 10 seconds. So obviously, something goes wrong. And I did not deploy any broken service. It's just using fault injection mechanism of Istio. So first of all, you can see how it will affect your production. Second of all, you can test your microservice architecture without really broken your services. Okay, so let me apply the cleanups again. And let me refresh the game. So now everything works fine. So is there any player called Athena NASA? No one with Athena NASA? Okay, so maybe the second one, Aphrodite Orbital Sciences. Is it present here? No. Okay, something strange. So yeah, because you have to make the high score from one time. So okay, in this case, the best question will get the prize. Okay. So while you are playing the game, let me introduce the new version of the game, because I consulted with the scientists and they told me that my meteors doesn't behave like real meteors. So that's why I will try to upload the new version 2 of event service. Let me, meanwhile, take a look at the metrics. So let's take a look at event service metrics. Let me refresh it. Still, something goes wrong. Okay, so 19. So we can see that there are requests here. We can see the duration of the requests. So it's the real environment traffic. So metrics told me that everything is okay. But I heard that somebody was laughing. I don't know why. Because the new version should be like the real world, real Mars environment. Let me try to play the game. So, I don't know. Feels okay for me. I don't know. Do you think that it's unplayable game for now? I was able to make, I don't know which score. Let me try again. You see, I can move forward and I get 42. So fortunately for me, I was using the rolling updates mechanism of Kubernetes. What is rolling update? So first of all, rolling update will allow me to get zero downtime deployment. And I will be able to deploy my new version of service one by one, and user won't experience any downtime. And this helps me. The good news is that I can revert it in the same way. But the bad news is that everybody that just played this game during this time got affected by the new version. So for now, I have a lot of angry users that think that I shouldn't be a game developer because you saw why. The better option would be to use canary release. So the canary release is will allow me to have two versions of my service at the same time. And instead of pointing all my users to the new version, I will just point a small amount of users to the new version, or some specific users. Let me try to apply it in practice. So first of all, I should clean up, so revert it back. And let me deploy the new version of the service. Service version 2. Okay, so it's deploying. If I will restart the game, I didn't start the event service yet. Okay, so it's up and running. So for now, you can see that I am being load balanced before two versions of the service. I can apply the configuration to point only the specific user to the new version of the service. Let me refresh the game and see I'm an Atalanta GPL. So let me point all the GPL rovers to the new version of the service. They will be our canary users. So I will change the configuration here, and I will apply this configuration. Okay, so I'm a GPL user, so if I move forward, I can see that I'm redirected to the old version of the service. I mean, to the new version, to the version 2, which is not playable. So I can have feedback from the real users, and still I don't have 100% of the users that will be angry. So I can just revert it in case something goes wrong with the real feedback. And if I restart the game, now I'm a Athena space dev, and I will move forward. I can see that I can still, I'm still redirected to the old version, which is stable, and I'm sure that it works fine. So this is a canary release. Okay, so let's move back to the presentation. Okay, so we saw the canary release. So the question is, what's next? Is it enough to have Kubernetes and Istio for achieving fault-tolerant application? As you know, if your system is more complex, the more things can go wrong. And by running your application in Kubernetes and having Istio on top of it, makes your system actually more complex. And this means that more things can go wrong. This is the first issue. The second issue is that we take a look only at some problems that may occur. We didn't take a look at the problem that can occur with your state of your application, with the database or something like this. So it means that you actually have to build the fault tolerance not only on the infrastructure level with Kubernetes and Istio, but actually in the code. How to do that? I can suggest you, first of all, the talk from the previous year, Devoxx Ukraine, from Mikita Prochenko and Alex Borisov. So it's a great talk where they will explain you how to build a fault tolerance using gRPC and REST. And the second one is a book called Patterns for Fault-Tolerant Software. It's an old book by Robert Hanmer, but it's still actual, and all the patterns described in this book must be actually applied to your application. So here is the source code for the demo that you have seen, so you can try to run it on your own Kubernetes cluster. So that's it. Thank you very much. So if you have any questions, I would be glad to answer, because I have a prize that I should give to someone. Okay, so sorry, there was first question. Okay, yeah.
So could you please tell us more details about how Envoy is used in your setup?
So Envoy is a sidecar proxy which is used by Istio by default. And actually all the traffic that goes to your service and from your service goes not directly to the service that you want to talk to, but through the Envoy. So it goes to your service in Envoy and then to your service, and outside of the service in the same way, like to Envoy and outside. So this is a basic concept of the service mesh mechanism. So Istio is one implementation of service mesh. Okay, so next question. Okay, anyone?
So, I heard that liveness probes are considered harmful when it comes, let's say, for when we have a Spring Boot application with actuator inside, and that can be dangerous to talk to the actuator health endpoint and target the liveness probe.
So this is because basically of the Spring Boot.
Internals.
Yeah. So of course, when you are set up some probes, you should be considering your application. Because if you have some vulnerabilities inside of the framework that you are using, then it's better not to use the actuator in this case. So maybe build your own health check. Maybe don't use it at all, but in this case you will have to implement the mechanism of health detection somehow. So of course you always should consider your application. Okay, so there was one more question.
Why no one talks about database and state default tolerance? I start feeling that that's the weakest point, and that's why I should not start doing that.
Yeah, of course you should consider your state, your database. It's another topic, completely another topic, and it's really huge. So there could be a lot of other presentations explaining how to build the fault tolerance when you're using your data, your state. So yeah, of course, this is a huge topic that you always should consider, but I'm not covering it in this talk. Yeah. Any other questions? Okay, so in this case, thank you. So about the endpoint, I think it's a great question. So just, I have a prize for you. So after the talk, just come and get it. So thank you very much. So enjoy the conference.